Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 110, balanced binary tree. Given a binary tree, determine if it is height balanced. Okay, what is meant by height balance? See here, take for example, it is our binary tree. Okay, now if I take this tree, this node, and I want to find whether it is height balanced or not, just see here. What is the maximum height of the left subtree? I can say the maximum height of the left subtree is only one. Okay, now what is the maximum height of the right subtree? I can say this is one of my path and this is one of my path. Okay, and these two will yield how much? Up to 2 height. Okay, this height is what? The maximum height is 2 only. Okay, so the difference between the left subtree and right subtree will be what? 1. So if the difference between the left subtree and right subtree is less than or equal to 1, then we can say it is a height balance. It is a height balanced. Can you understand this? Okay. From this 3, it is height balance. Okay. From this 9, it is height balance. Yes, because there is no child. Okay. It is also none. It is also none. So it is also height balance. Whether this 20 is height balance? Yes. The left subtree height is 1. Right subtree height is what? Also 1. Whether it is 15? Yes. Whether it is 7? Yes. So this entire tree is what? A height balance tree. Okay, if each and every node is height balance, then we can say this entire tree is a height balance tree. Okay, let us see this second example. See here. From this one, what is my height? I can say the left subtree height is 1, 2, and 3. So the left subtree height is what? 3. So I can say the maximum height of this left subtree is 3, and what's the maximum height of this right subtree? It is only 1. What's the difference? I can say the difference is 2. 2 is what? Greater than 1. So I can say it is a false condition, right? Because see here, it is not a height balance tree. Yes. Okay. Now, how to approach this problem? Just observe this. This is our given input, right? Okay. Initially, I am at this node. Okay. Now I am going to check whether this tree is height balance or not. Okay. Just check. So when I'm going down and find the maximum height of the left subtree, it is 1. The maximum height of the right subtree is 2. So difference is what? Only 1. Which is what? Which is less than or equal to 1. Okay. Okay. Now I will go to the next node. I will traverse to the next node and I am going to check whether this node is height balance or not. Okay, this node is height balance. Now I am going to this 20 and I am checking whether it is a height balance or not. Okay. Just check. It is 1. And here also it is 1. So it is also height balance. Now I will go to this 15 and check height balance and go to this 7 and check it is a height balance. Can you understand this? So this is a simple brute force approach. Simple brute force approach, and this time complexity lies between what? O of n square. And space something between what? O of h. H is what? The height of this binary tree. Right? Okay. So this is the brute force approach. Now, it is quite not an optimal solution, right? Because it takes much time. Okay. Can we reduce it? Okay. Let us check about it. Okay. If take for example, this subtree, the right subtree is not a height balance tree, then I can say this tree is not a height balance thing, right? Can you understand this? Okay. If this left subtree is not a height balance subtree, then I can say the whole tree is not a height balance thing, right? So just see here. Now I'm going to do like a regression. Okay. Why I'm doing a regression? Just observe. We have a larger problem. Now I want to divide that problem into a sub-problem. And I want to find the solution for the sub-problem such that I can find the solution for the main problem, right? Okay. First of all, I am at this node. Okay. Now I am going towards the right. Yes. Then again I will go towards the right. What is the value? It is null. So it will return what? It will return that there is no more. There is no more. And it returns what? 0. What is height? It is 0 only, right? Okay. Then it goes to the right subtree. And what is the height? It's also 0. So it also returns what? As 0. Okay. Now for this 9, what is the height of this 9? I can say the height of this 9 is something like maximum of left subtree and right subtree height. So it is what? 0. It is what? 0. Okay. Now this 9 will return what? This 9 will return what? 0 plus 1, because this 9 also one of the path, right? So it will return what? 1. Can you understand this? Now I will go and go to this 20. Then I will go to this 15. Then this 15 child is one of the child is none and another child is also none. So this child returns 0. Again, this 15 goes here. Then it also return what? 0. Now, hold on. What is the height of this 15? What is the possible height? So it is 0, 0, right? Left subtree is also 0. Right subtree is also 0. Now, we want to do equation operation on it. Okay, whether this left subtree is and the right subtree difference is less than or equal to 1. If it is greater than 1, what should I do? I should return false, right? I should return false. That we can see in the next trick. I will take this as our example. Next time, I will take this as our example. That time, we can understand what will happen. Okay, now, just come up. Now, I will return here. While returning here, I will do what? A maximum. I will take the maximum among the right and the left subtree, height, and what is the maximum of this? It is 0 only, right? So 0 plus 1 is equal to 1. So this 15 returns what? 1 only. Now, this 20 goes here. And for this 7 also, it is none. It is none. These 2 returns 0, 0. Then it will return what? 0 plus 1 is equal to 1. So it returns what? 1 only. Can you understand this? 1 only. Now, for this 20, my left subtree maximum height is 1. My right subtree maximum height is 1. So what is the maximum among this? It is also 1. And what is the difference among this? It is 0. 0 is what? Less than or equal to 1, right? Okay. Now it's time to return. Okay. I'm returning. Now, while I'm returning, what's the return? So maximum among this 1 and 1 is 1. So 1 plus 1 is 2. So I should return 2. So from my right subtree, it is like it returning 2. And from my left subtree, it returning 1. So what is the difference? It is 1. So 1 is less than or equal to 1. So that condition is satisfied, right? So I return what? A value. A value. At last, I'm going to check whether it contains some valid values. The root contains some valid values. Okay. It contains what? It contains the maximum among this 1 and 2 plus 1. So it will be 2 plus 1 is equal to 3. Understand? So this root will return what? 3. So I return what? True. You may ask, if it is 3, then why should we return true? Okay. Let me take this example as the next example. Okay. Then you can understand what it means. So just put 1, then 2, 2, then 3, 3, then 4, here also 4. Now this, take for example, this is my tree. Okay, now you will understand why I just wrote I just written true if the value is something which can be possible. Okay, hold on, I will say you. First, I am at here, right? I am at here. Now I will go down. Okay, then again I will go down. Then again I will go down. When again I go down, it will be what? A null value, right? It returns what? A 0. Okay, here also it is null value. It goes here and it also returns what? 0. Okay, for this fourth node, what is the maximum among the left and right side is 0 and 0. And what is the difference between them? The difference is what? Difference 0 minus 0 is equal to 0 only. 0 only the difference, right? 0 is less than or equal to 1. So it is valid. So I will return what? The maximum among them plus 1. That's plus 1. Why? Because we include this 4 also. So it will be like it returning 1. Okay. Then for this 3, again I will go for this right side. Right side. And this right side will also return what? Here it is 0. For this it is 0. Then it also return what? A 1. Can you understand this? It also return 1. Now for this 3, my left side is returning 1. My right side is returning 1. So I can say, what's the difference between them? For node 3, what is the difference? It is 1 minus 1 is equal to 0. 0 is less than or equal to 1, right? Right? And what should this 3 return? This 3 return the maximum among left side and the right, left subtree and right subtree plus what? This 1 represent what? This 3 is included. This 3 is included. While I am taking this 2. Okay. So it returns what? It returns 2. Can you understand this? It returns 2. So my node of 2's left subtree returns what? 2. Now then I am going to the right subtree. Now it also has what? Null and null. So this null returns 0. This null returns 0. Now what is the maximum among this? It is 0. So it returns what? 1. So my right subtree returns what? 1. So what is the maximum among this? I can say the maximum among this is 2, 1 is 2. And I will include this second node also. This 2 node also, right? So it will be what? 3. So it will return what? 3 here. It will return what? 3 here. And also I forgot to check, right? So this 2 and 1 will be a difference, right? What's the difference? It is 1 only. So it is what? Less than or equal to 1. The absolute difference. We want to take the absolute difference, okay? the absolute difference of this is less than or equal to 1. Okay. Now it returns 3. So my left subtree returning what? 3 on this 1. Now it goes to the right subtree. Now once my right subtree, it is 2. Then again it goes down to the left subtree. Okay. Now it is what? Null. So it returns what? 0. It also returns what? 0. Now comes the twist. Now comes the twist. See here. It returns what? 1. So see here. Here it is 3. Here it is 1. So if I take the absolute difference between this 2, it is 2. 2 is what? Greater than 1. Then I should return what? I should return the int max. I should return the int max, or I can return float of infinity in Python. Float of infinity. Then beyond this, wherever it returns, the value will be written what? Float of infinity only. You understand? Float of infinity plus 1. What is float of infinity only? So as a final result, I got what? Float of infinity. So it means what? False. If the final result is not a float of infinity, then the result will go true. Can you understand this? Okay. Now, what's the time constraint based on the for the solution? I can say my time constraint will be O of n because I am just traversing each and every node. And what is my space of t? I can say I am taking this is in the recursive stack, right? In the internal stack. So this each and every type of field will be there. So it will be what? O of 8. It will be what? O of 8. Of x. So this is my time and space velocity analysis. Now let us see the code. See here. First of all, depth tree of root. Okay. Now if there exists the root is equal to null, then what should I do? I should just return 0. Okay. Now left is equal to 1 plus tree of this root dot left. I am traversing to the left subtree and I am adding 1 plus. Why I am adding 1 plus? Because see here. I am taking what? I am taking that current node also. That's why I am adding what? 1 plus. We can also do without this also. We can do this. We can take a left subtree and a right subtree. At last we can add 1 and send it. It's also correct. Can you understand this? It also correct. It also yield the same output only. Okay. Now then if absolute difference of left minus right is greater than 1. It's greater than 1, which means what? It is a false condition. So at a false condition, what should we do? We should return float of infinity, such that wherever it returns, whichever the number we add on it, the result will be what? Float of infinity only. Okay. Then we should return what? 1 plus maximum among left and right. If this is not the case, if the condition is true, which means it is balanced, the current node is balanced, then what should I do? I should return 1 plus maximum of left comma right. Can you understand this? Then I am calling the tree of node, this function, and if this function's return value is not equal to float of infinity, then I should return true. Else I should return false. That's the meaning of this last line. Let me submit it. Yes, it is submitted successfully. Thank you.
The other